This video, we're going to look at the properties of quadrilaterals. A quadrilateral, of course, being a four-sided shape. So previous knowledge required would be to understand symmetry and rotational symmetry. Okay, so describing quadrilaterals, well, first of all, we need to know the 6 names. Now, these names were on the front page as well. So we have a square, a rectangle, a kite, a rhombus, which is a square pushed over, a rectangle, or sorry, a parallelogram, which is a rectangle pushed over, and we have trapezium. So we're going to talk about each of these 6 quadrilaterals in turn. Okay, so here is the square, and here are the properties of a square. All sides are equal, so I would use this to show that. All angles are 90 degrees. Opposite sides are parallel, so those two go in the same direction as do those two. The diagonals are equal in length and bisect at 90 degrees. So what I mean by that is if I draw my 2 diagonals, they're the same length, obviously, both they also bisect, so cut each other in half, and that's a 90 degree. There are 4 lines of symmetry, 1, 2, and then both diagonals. And it has rotational symmetry of order 4. So if I was to start this shape and turn it round, it would fit on itself 4 times. 1, 2, 3, and back to the start, 4. So that shape is a square. The rectangle, so very similar. Opposite sides are equal, so that one is equal to that one. Those two are equal. All angles are 90 degrees. Opposite sides, yet again, are parallel. Diagonals are equal and bisect. So here there is no mention of 90 degrees. And you can see that one's acute and one's obtuse. I have 2 lines of symmetry. And those 2 lines, of course, are there and there. And it has rotational symmetry of order 2. So once, twice back to the south. Look at the kite. The kite has 2 pairs of equal sides, and they're talking about length there. So it's got that one and that one. Those 2. One pair of opposite angles equal, so that angle is equal to that angle. Diagonals cross at 90 degrees, so they're not the same length. They don't bisect. They cross at 90 degrees. One line is symmetry, and that's it down the middle, and it has no rotational symmetry. We've torn that shape. It doesn't fit on itself at all as it gets back to the start. The rhombus, all sides are equal because it is a square pushed open. All sides are equal. Opposite angles are equal, so opposite sides are parallel. Diagonals bisect at 90 degrees, so they're not equal in length. You can see that this one is longer than this one, but they do bisect at 90 degrees. 2 lines of symmetry, and that's this one and this one, they will fold across. And rotational symmetry of order 2. Once, twice, and then back to the start. Parallelogram. Opposite sides equal. Opposite angles are equal. Opposite sides are parallel. Diagonals bisect each other, so these Just cut each other in half. That's halfway, midpoint on both lines. It has no lines of symmetry, so you can't follow that. But it does have rotational symmetry of order 2, once and twice. Then I have my trapezium. Now, a trapezium can look like different things. Here's is 3 trapeziums. All of them are trapeziums. This is an isosceles trapezium. These sides are equal and those angles are equal. And for a trapezium to work, one pair of opposite sides needs to be parallel. So they are parallel, and that is parallel, and in this instance, they are parallel, but they must be parallel. Okay, let's look and see what these questions look like. Which shape of my opposite sides are equal and 2 lines of symmetry? And I really recommend to draw the shape before you answer the question. The 2 lines of symmetry, so opposite sides are equal. So I'm going to put a tick beside that. Opposite sides are equal. Opposite side, then we have opposite sides. Opposite sides are equal. Okay, so let's cancel the down. Let's pick this one. 2 lines of symmetry. Well, this one's got 4 lines of symmetry. This one has 2 lines of symmetry. This one has 2 lines of symmetry. This one has no lines of symmetry. So my answer is a rectangle. Rhombus. Which shape am I? Diagonals cross at 90 degrees. So I'm going to put a tick for that diagonal. That one's got a 90 degree. That one does not. This one does not, does not. Rotational symmetry order 2. That one's got order 4. That one's order 2. 2. None. 2. None. So the only one that matches both of these is a rhombus. Okay, so here's some questions for you to have a go at. Press pause and the answers will follow in 1 moment. There are your answers.